This video is going over our practice problems today, which are mostly on adding, subtracting, multiplying, dividing, and solving our rational functions, our rational expressions. So for questions like 1 and 2, notice how we're adding and we're subtracting. So remember, right, in order to add and subtract fractions, you have to have a common denominator. Well, here in number 1, I notice not only are they different, but nothing can be factored. So they're just complete opposite. They have nothing in common, no common factor, which means we're going to just multiply them to each other. So the common factor in the end that we're going to be able to use to add them together, right? Because we're adding is x minus 6 times x plus 2. So that means here, if I have x minus 6, we're going to multiply 7 by x plus 2. So we're going to multiply by x plus 2 here. And then we're going to multiply 3x here by x minus 6. Now we just distribute, and then because we're adding, we're just going to go through then and combine like terms. So distributing 7 here, you now have 7x plus 14. Then after distributing that positive 3x here, we now have 3x squared minus 18x. Then combining like terms, we now have over, again, that common denominator. That's why we can add our fractions together, our numerators. We have here 3x squared, but then minus 11x from 7x minus 18x, then plus 14. So same thing in number 2. However, I'm going to look to see here with this first denominator because this can be factored. It's a trinomial. So what factors multiply to get 8 and add to get 6? 4 and 2. So now I notice here that this denominator is only x plus 4, which is this factor. So what factor is our second rational expression missing? The x plus 2. So I'm going to multiply by x plus 2 to get that common denominator, which in this case is x plus 4 times x plus 2. Now, we didn't need to do anything here with that first numerator, so I'm just going to bring that down. Now, notice you are distributing a negative 10, or you could distribute 10, but then don't forget to distribute the negative. But I'm going to go ahead and distribute this negative 10 here because this is subtraction. So when you distribute now, you end up with negative 10x minus 20. Now I can just combine my like terms here. So here in our numerator, you now have negative 8x from 2x minus 10x and negative 23 from negative 3 minus 20 over x plus 4 times x plus 2. Now question number 3 and 4. We don't need a common denominator in order to multiply and divide. So with multiplying, I'm just going to go through and start factoring. Well, in my numerator, because we're multiplying straight across, in my numerator here, I just have 5x. So I'm just going to bring down 5x. But this is a difference of two perfect squares because I have x squared, which I can take the square root of, and 49, which I can take the square root of. So this is x plus 7 times x minus 7. Then I can now go to my denominator here. So I've got x plus 7. I'm just going to bring that down. Now notice we do have these two terms. There is a GCF of 5. When you take out 5, 15 divided by 5 is 3. So 3x, and 20 divided by 5 is 4. Now we can start simplifying. I notice here not only do the x plus 7s cancel out, but technically, even though this has x, this is 5 divided by 5, which is 1. So now it's just 1x here. So in the numerator, you have x times x minus 7 over 3x plus 4. Now, of course, you could also distribute that and get x squared minus 7x. So number 4, because it's division, remember now we need to keep, change, flip. So just like if you were dividing fractions, same thing with our rational expression. We're now going to multiply by the reciprocal, flip it. So now it's 3 over x squared minus 12x plus 24. Now, just like here with our multiplication, we go through and start factoring because we're just multiplying straight across. Well, here I just have x minus 10 and then just 3. So this is 3 times x minus 10. Now, in the denominator, notice how you have a GCF of 3x. Notice how they both have an x term here. So I'm going to take out the GCF of 3x, and now I'm left with x minus 3. Now I do have a trinomial here. So what numbers multiply to get 24 and add to get negative 12? And sorry about that. As I was solving, I realized there was the typo here. So this was actually supposed to be a 20, not 24. So what two numbers multiply to get 20 and add to get negative 12? Negative 10 and negative 2. So negative 10 and negative 2. So now I can start canceling out. Well, here the x minus 10 cancels out, and so does 3 over 3. So again, even though that says 3x, that's 3 divided by 3, which is 1. So that's just 1x here. Now notice, see how there's nothing in our numerator? That means we still have 1. So this is 1 over x times x minus 3 times x minus 2. So now in number 5, notice we're back to subtracting. And in order to subtract, the denominators have to be the same. But now notice how they're completely different. So that means we're just going to multiply them to each other to have that common denominator of 2 times x plus 3, which means to get the common denominator, our first fraction, because it only has the factor of 2, we're going to multiply by x plus 3. That means our second, we're going to multiply by 2. So in distributing 9x here, I now have 9x squared plus 27x. Now I'm going to show the other way of subtraction besides thinking about it as distributing a negative. So I'm going to bring down my subtraction, but now make sure that we now distribute the 2 here. We could distribute 2 or x minus 8 to 2, but now I've got 2x minus 16. Now again, because this is subtraction, we are now going to distribute the negative, so or negative 1. I've got in my numerator 9x squared plus 27x, but now minus 2x plus 16. That is now the expression in the numerator after distributing negative 1. Now combining like terms in the numerator, we now have 9x squared plus 25x from 27 minus 2 and plus 16 over 2 times x plus 3. Or you could also distribute in the denominator to have 2x plus 6. Now, question number 6, we're solving an equation. We're solving for x. So I'm going to make sure that I identify what values can x not equal, because remember, our denominator cannot equal 0. So here I've got x minus 4 cannot equal 0, so x cannot equal 4. And in this case, x cannot equal negative 1/3. Now we just are solving, but I do notice that we have 2 completely different denominators. Nothing can be factored. So I'm just going to go through and cross multiply. So here I've got 5 times x minus 4, which is equal to 2 times 3x plus 1. Now I'm going to distribute. So now I've got 5x minus 20, which is equal to 6x plus 2. Now notice you're just solving a multi-step equation here. So I'm going to gather my variable and subtract 5x from both sides. Now I've got negative 20, which is equal to 1x or x plus 2. Now to solve for x, subtract 2 from both sides. And x is equal to negative 22. Now question number 7, we're again solving an equation. So again, notice how our denominator, x cannot equal -8. And that is the same for both. So notice how here, if you were to solve, x cannot equal -8. So that means here, well, I notice that I'm subtracting these two rationals to equal this rational expression here. Now I notice I can factor this denominator because there's a GCF of 3. When I take out 3, I'm left with 3 times x plus 8. That means here, if I just have the factor of x plus 8, well, what's missing? 3. I just need to multiply this first here by 3. Then the second rational here, our fraction, only has 3. So what factor is it missing? It only has 3, x plus 8. So I'm going to multiply by x plus 8. I'm running out of space here. So now that I can get the denominator the same, we're just going to focus now on the numerator. So here I've got 3 times x, which is 3x. Now notice this is a -5 because it's subtraction. So -5 here, or distribute 5, but then don't forget to distribute the negative. So this becomes -5x minus 40 after distributing -5 because it's subtraction, which is now equal to 2x plus 15. Now we're going to go through and solve for x. Now I do notice on the left side here we have like terms to combine. So this now becomes -2x minus 40. Now I have variables on both sides. We just need to gather. So I'm going to add 2x and get rid of that negative here. This is -40, but now equal to 4x plus 15. Then subtract 15 because you're just solving for x. You're solving a two-step over here on the right. Now I've got 4x is equal to -55. You're still multiplying x by 4. So divide now by 4, and x is equal to -55 over 4, which is not extraneous. So question number 8, same thing again. We're just now adding two rational expressions equal to another. And again, denominators need to be the same. I do notice I can factor here. So what numbers multiply to get -5 and add to get +4? +5 and -1 here. And so notice how these are the two factors, x minus 1 and x plus 5. So here, this factor is x minus 1, so that means I need to multiply by x plus 5. And then x plus 5 is here, so the missing factor is x minus 1. Now that we'll have the same denominator, we can just focus on the numerator. But before we do, and I just realized this, I apologize, we need to make sure to identify what are the extraneous solutions. So what makes our denominator equal to 0? So x cannot equal +1 because that's x minus 1, so +1 and -5. So these are the two extraneous values. So now when I distribute 6 to x plus 5, you now have 6x plus 30. Then distribute x to x minus 1, and now you have x squared minus 1x or minus x, which is equal to 15 minus 3x. Now I do notice I have like terms on the left side that I need to combine. So here I've got 6x minus x. So I'm going to rearrange this in standard form. So x squared, but now plus 5x from 6 minus 1 plus 30, which is equal to 15 minus 3x. Now notice in this case, we're solving a quadratic because you have x squared. And quadratics always have to equal 0. I need to subtract 15, but I also need to add 3x. Make sure to line up those like terms here. So the quadratic we're now going to solve because it has to equal 0 is x squared plus 8x plus 15. Now we can solve by factoring. What two factors multiply to get 15 and add to get 8? 5 and 3. That means because we're solving, x is equal to -5 and -3. But Go back and check your extraneous. Notice how -5 is an extraneous solution, meaning it cannot equal -5. So the only answer is -3. Now, question number 9, notice how we are adding two rational expressions. So again, adding, you have to have the same denominator in order to add. Now, I do notice I can factor this denominator here. So what factors multiply to get -6 and add to get 1? +3 and -2. So now notice the other only has the factor x minus 2. So what is it missing in order to add? X plus 3. So that's why we're going to multiply by x plus 3. Now that I've got my common denominator of x plus 3 times x minus 2, we can add our two rational. So I'm going to bring down 8x minus 13, but now distribute and see how we're just adding. So we're going to distribute that positive here and then combine like terms. So now I've got 4x squared plus 12x. Combining like terms, you now have 4x squared, but then 20x from 8x plus 12x minus 13 over x plus 3 times x minus 2. Now in number 10, you're multiplying. Remember, multiplying, the denominators do not need to be the same. We're just going to start factoring because here we're going to multiply straight across, and then we're going to cancel out what's our common factors here. I can't factor x plus 3, so I'm going to bring that down. But here I do have a GCF of 2. So after factoring out 2, you're now left with x plus 5. Then going to the denominator, here I do have a GCF of 2. Now this one's a little different because I have an x squared here. See how this says x squared, but this only has x. I'm going to put this one to the side here and notice how I'm going to take out 2. And I'm left with x squared minus 9. Because now notice, can I still factor this? Yes, because this is a difference of two perfect squares. So even though you had a GCF of 2, you can still factor that to x plus 3 times x minus 3, because that's the difference of two perfect squares. Then here we have our trinomial. So what factors multiply to get 10 and add to get 7? 5 and 2. Now I can start canceling out common factors. X plus 3, x plus 5, and 2 divided by 2, which is 1. So notice how here, even though we canceled everything out in the numerator, you are still left with 1 in your numerator over x minus 3 times x plus 2. Now 11 and 12, we're getting into review of the graphs. What is the domain? Well, remember guys, domain is x values. So what x values make this not exist? Now I could factor this just to see and double check if there's a hole. What numbers multiply to get 4 and add to get 5? 4 and 1. Then in the denominator, you have again a difference of the two perfect squares. This is x plus 3 times x minus 3. So really, the only thing we need to focus on, if I'm looking for x values where it's all reals except for what x cannot equal, we're focusing on the denominator again. So here, remember, the denominator cannot equal 0. That's why here x cannot equal -3 and +3. So it's all reals, the domain, except for -3 and 3. Now question number 12, which statement is true? Now notice how we're going through these different parts, but there is also an end behavior here. So this one, I could go through calculations, but I went ahead and used Desmos because you could also use Desmos and graph this. The only thing though is remember in Desmos, you will not be able to see the whole. So here's the graph because I'm going to look to see which statement is true. So D says as x approaches infinity, my f of x, the end, is going to also go all the way up to infinity. So now looking at the graph, here. Notice here on the right side, so here on the right side, that this is our end as x's are approaching infinity. But what I do notice is, as I'm looking, that end, that there is a horizontal asymptote. So notice here on both ends, and I can zoom out so you can see, notice how here that it's approaching this horizontal asymptote at y is equal to 1, which means that this end is not going all the way up to infinity, it's approaching 1. So that last statement is false because we do have that horizontal asymptote, so it's approaching 1, not infinity, which means that B is also false because this says there's no horizontal asymptote, but y is equal to 1. Then we could also check because notice how degrees are the same. We just take the coefficient, which is 1 over 1, making y is equal to 1. So I'm going to go back to the graph to see the vertical asymptote. Well, notice the vertical asymptote again. I'll zoom out. Notice how here we do have a vertical asymptote in the negative, and notice how our graph is approaching, but never reaching and getting closer and closer to -7. So notice here, again, how it's approaching, but never reaching -7 here. So we do have that vertical asymptote at -7. So that statement is our true. I'm going to check though and make sure that our whole is false. So remember, the whole is the common factor. Well, I'm going to factor my numerator. And here, what numbers multiply to get -12 and add to get -4? -6 and +2. Then in the denominator, what factors multiply to get 14 and add to get 9? 7 and 2. So notice how we do have a common factor of x plus 2. But remember, when identifying these characteristics, it's always equal to 0. So that's why it's not x is equal to 2, but x is equal to -2. That's the x coordinate for the whole. So that's why A is false and C is true. Also notice in the denominator that vertical asymptote. There's x plus 7, which again equal to 0. So it does check off that x is equal to -7. Now question 13. This is going back and reviewing here how Isaac has 3 total zeros. So we need to keep in mind 3 total zeros. Each zero has an odd multiplicity, so 1 or 3. An end behavior as x approaches positive infinity, f of x approaches or g of x approaches negative. So as the x's are approaching positive infinity, the g of x is approaching negative infinity. I'm going to go ahead and start looking. As x approaches positive infinity, notice how this end is going up towards positive infinity on the right side. So A is not my answer. Same thing here. As x's are approaching positive, notice how the end is also approaching positive. The values are approaching positive. So B is not our answer. However, C could be because now we're going negative. The f of x or g of x values are going negative. And same for D. As we're going to the right towards positive, the x values, the g of x values are going down towards negative. So we're down to C or D. Now there are 3 total zeros. So notice how this has a multiplicity here of 2 and 1 and 1. So notice how that there are 4 total zeros. So that's why here the answer is D, because notice how this is a slice, which is 1, slice, which is 1, and slice, which is 1. So every zero has that odd multiplicity, and there are 3 total zeros. In question 14, we have a two-parter. You're given the equation and how it has a factor at x minus 3, or again, crossing at positive 3. Which of the following, though, correctly describes the roots? So if I need to know the roots, which are the zeros, the x-intercepts, I need to see the graph. So go through then and graph this equation. I'm going to go through and graph. And notice how here, there is your net positive 3, right? Because the factor said x minus 3, so that's why it's at 3, 0. Because remember, when factored form, change the sign. And we also have another 0 at 0, 0. This means that there are two real zeros because it's crossing the x-axis here at these 2 points. So going back now, that means here that that's why the answer is B, because there were just two real roots, meaning the other two are imaginary. Now, what are the other factors of the polynomial? Well, this means if this is a factor, x minus 3, to find the other factor, I can now divide. So I'm going to use synthetic division because x has that coefficient and exponent of 1. So positive 3, then set up the coefficient. So 3, negative 9, 1, and negative 3. No zeros needed, no missing terms. Then always bring down the first term. Multiply below, 3 times 3 is 9. Then add above, you get 0. Then 3 times 0 is 0. Add, you get 1. 3 times 1 is 3. And there's your remainder of 0. So remember, right, if you have a factor, the remainder is 0. Now this started at x to the 4th. So this means here I've got 3x cubed, because this is our x cubed, 0x squared, so I'm not going to write that, but plus 1x. So when dividing, I ended up with 3x cubed plus x. Now notice though, I can factor this because there is a common factor of x. So when I take out x, I'm now left with 3, but now x squared. So x cubed now down to x squared. Then if I take out x here, I'm still left with 1. So that's why here the answer is D. So question 15, again, we're using this function, but now in factored form to answer the parts 1 and 2 here. So in part 1, which of these correctly identifies the degree and number of unique zeros? Remember, degree is our exponent. So the total degree is 2 plus 1, which is 4. So we have a degree of 4. So I'm going to mark off B and D. Now, how many unique zeros? Well, remember, guys, unique is not your total, right? Unique, think about unique as different. So how many zeros do we have? How many different zeros? Well, I've got x is equal to 5, x is equal to negative 3, and x is equal to 1. So there are 3 different or unique zeros. That's why the answer is C. Now, again, remember, I changed the sign here because this is all in factored form. Think about this like it's equal to 0. Now, part 2 is asking for the end behavior, which means I need to see it visually. So I'm going to go through, and again, then that means use Desmos and graph it to visually see what the end behavior is. So now I'm going to go through, and I've already graphed it. So now notice, if I were to zoom out, notice as the x's are going to the right, our end is approaching positive infinity. And on the, on the left side, as our graph is going to the left towards the negative on the left side, again, notice how our graph is going up towards positive infinity. So they're both ends are going up towards positive infinity. So that's why here, when looking at my answer choices, well, I'm going to mark off A because this says as the x were approaching negative, the end was approaching negative. Now here, negative to positive, positive to negative. So again, B is not our answer. As negative going to positive and positive going to positive. That's why the answer was C here. Notice how our both ends were going towards positive infinity.